Hi everyone, and welcome to today's talk on advanced layout animations in Compose. My name is Rebecca Franks, and I'm a developer relations engineer working on Compose at Google. And I'm joined by my colleague.
My name is Doris Liu, and I'm a software engineer, as you can tell, on Compose animation.
So today we're going to be talking all about layout animations and subsequently shared element transitions and a little bit about how they work under the hood. We've been busy working on shared elements, and in this talk we're going to cover a lot of the details that might help with the understanding of the complexities of how the APIs were built and help uncover a few more of the details around why certain APIs exist. So if you haven't done any Compose layout animations in the past, or if you weren't in Nicole's talk a little bit earlier, let's do a quick overview of how you can perform a basic layout animation. There are many different ways to do layout animations. So one of the ways is to use animate DP as state, or animate offset as state, and then manually change the offset modifiers with these animating values. In this example, we change the offset based on a click event. And we also know about animated visibility. When used in a column or row, it'll animate the size change, and other content will respond to this changing size.
Now that we have seen some examples of layout animations, how do they work under the hood? Let's look at this animated visibility demo again. As you can see, the top item is shrinking on its way out, and the bottom item is moving up along with it. This creates a very coordinated effect between the two items. How do we achieve this? That brings us to the principle of layout animations in Compose, which is when we animate a layout, we're making its animated size and position observable to the entire layout tree. That way, other layouts can see the change and respond to the change. In this example, the parent layout, which is the column of these two items, sees the change in the top item, so it resizes itself and moves the bottom item up along with it. This works pretty well, right? Let's look at another example. This is a more complex example with 3 items in a flow row. These 3 items are all animating its size through size animations. And as you can see, at some point, item B and C get pushed down to the next row when there's not enough space to fit them in the first row. The wireframes indicate where A, B, C believe their target bounds will be. And since there's a jump onto the next row, we also have a position animation for each of these items to smooth over that jump. And because the target bounds are changing every frame, the position animation ends up chasing the bounds. And it results in this really reactive animation that doesn't look super great. What's causing this? Well, the issue is that only current animation values are observable in the tree. No item knows how big the other items are going to be. So for the lack of other choice, they can only rely on other items' animated value to calculate their target. More specifically, B's position depends on A's size. Since B only has visibility to A's animated size, whenever A's animated size changes, B's target position changes. And that is every frame. And that's what's causing this reactiveness in the animation. And I think you will agree with me, this doesn't look ideal. What if we could observe target values of the animations in addition to the current values? Now that brings us to look ahead. It's a new feature that we recently built in Compose. The design intention for look ahead is we want to be able to just look past any ongoing layout animation, just see the target for all of the ongoing animations. And when we observe the animation targets, we can also use the targets in the layout calculation. So that would allow us to calculate the final stable layout. The stable layout in this case is indicated with wireframes. Now, with the stable layout, we can just base our layout animation on the stable layout instead of on other animations' animated size. That would avoid the interference among animations. And if we put these two examples side by side, with or without look ahead, I think you will agree with me that the version with look ahead looks much more coordinated and intentional. Now let's define what look ahead is. It's a new layout pass, and its intention is to observe the layout animation targets in order to calculate a stable layout. The stable layout is normally not rendered on screen, except in this case. For visualization purposes, we're showing the stable layout with wireframes. After look ahead, we'll have the standard layout pass, which we also call approach pass. The standard layout pass produces what you see on the screen, the layout that you see on screen. And the role for approach pass is to animate the layout from their current bounds to the target bounds that's indicated by the stable layout. A good metaphor for this is hikers need to first look ahead to their destination before they approach their destination. And similarly, look ahead pass would help calculate the destination of all the layouts, which we also call stable layout. And then the look ahead pass will kick in and animate all of the layouts towards the stable layout.
So now that we understand a little bit about what look ahead is and how it helps us unlock better animations in Compose, let's take a look at the higher level APIs, higher level shared elements APIs that are built on top of look ahead. So we're going to be working on JetSnack, an app that allows you to order your favorite snacks. And we have two screens, the main content and the snack details. And we would like to share a few elements from the card to the snack detail screen. And if we look in detail at which elements we would like to share between these two screens, we see that there is a gradient background, the bounds, the image of the cupcake, and the title and the tagline that we would like to share. Let's see how we can do this. So the first composable that we need to use is the shared transition layout composable. Our UI looks a bit like this. We have used animated content at the top level between the two screens, and by default, this will fade between the two states when the show details variable is updated. So to get started with shared elements, we need to wrap the top level layout with the shared transition layout. And this layout provides a shared transition scope, which is responsible for finding the matching shared elements, doing the look-ahead calculations between the two states, and removing elements from their current rendering position into a layer above the content, which can grow and shrink to its desired size. The animated content composable, it provides us with an animated visibility scope. And this scope is used to drive the progress between the two states of the shared element transition. And it's used to determine what should be displayed on screen at any point. So it's worth noting that this animated visibility scope is provided by a few different layouts, such as animated content, animated visibility, and a nav host. So this means that you can use shared elements with these different composables pretty well. And these scopes are pretty important to understand as they are key elements of the shared element APIs. The next step is that we need to pass these scopes to our main details and our main content and our details content to be able to gain access to the shared element modifiers. If you have a very large application, you should probably use composition locals at this point to avoid having to pass it very far down your hierarchy. Okay, so the plumbing is set up, but we also need to tag the individual items, which brings us to looking at the shared element modifiers themselves. So let's start with the image first. This is going to be the first element that we share between the two states. In each of the main content and details content composables, we find the matching image composables, and we add modifier.shared elements onto each matching item, passing in this animated visibility scope and using with shared transition scope to ensure that we have access to these shared element APIs. And we also pass a unique key for the item. This can be a data class if you want, as long as it's unique, which usually means if you're in a list or something like that, you want to add on an ID. We also then add the same matching modifier onto the details content image composable, just so that it can do the matching correctly. And with this, we can see that we have a nice, simple shared element of the image between the snack and the detail screens. Of course, though, we want a bit more, right? We'd like to be able to set a custom animation spec, to be able to define how the animation should transition between the start and end states. We'd like it to be a little bit more expressive and have a custom spring. So we can adjust the shared element modifier and specify the bounds transform parameter. and this gives us information to the initial size and the target size of our animation. And we return a custom animation spec here. In this example, we set a different damping ratio and stiffness for it. And we need to define this on both shared element modifiers. So now the animation performs the transition with a little bit more bounce between the two states. So we have our basic image shared elements. Let's talk a little bit about modifier.sharedBounds. So shared bounds is similar to shared elements, and a lot of the APIs are consistent between the two. The difference as to when you would reach for shared bounds versus shared elements is that shared bounds should be used for content that is visually different, but should share the same area as it transitions between the two states. So it's very similar to how animated content works, in that you need to provide an enter and an exit transition for that, and both content will be visible on screen during this transition. Whereas with shared elements, only the target content is rendered on screen at any point. So it's useful for things such as cards that transform between different areas, or text such as bold text versus transitioning to italic text, and asynchronous images, as you may want to load up like a higher resolution image as it transforms. So, looking at our elements in our shared element transition, we have the background gradient, and this looks slightly different on the detail screen versus the card. So this would be using a shared bounds. The bounds is the actual whole container of the card, and this should also then use shared bounds. The image, we will continue to use shared elements here, as we are using a standard static image. And the title should also use shared bounds, because this text, if you can see the difference between the two, it changes size and it goes from bold to bold italic. The tagline, we also want to use shared bounds here, since this changes in text size between the two screens. So because we're using shared bounds for a lot of these, we're just going to focus on adding one to the bounds of the card, but the others are exactly the same. Okay, so we have our main content that lives inside a card. Let's add a shared bounds modifier onto it. So we add it with a new unique key and the animated visibility scope that we've passed down. And jumped the gun. And we apply the same thing to the details content too, applying the shared bounds with the exact same key as the main content. And in this case, it's on a column of the whole detail screen. So now we have a bounds that transforms between the two states. This is kind of looking cool, no? We've also sneakily added shared bounds onto all the other elements, such as the tagline, the text, and the background. So notice how the donut word animates from a regular to italic text. So this looks good, but there's a little bit of an off feeling between the two states. We can see that the end state is a different aspect ratio from the start card, causing a little bit of an unequal overlap between the two different sized items. So this leads us to talking a little bit about resize modes. There are two options for your different resize modes: scale to bounds and remeasure to bounds. Scale to bounds is the default set on the API, and it performs what we call a graphical scale between the two states, meaning that it will maintain the same aspect ratio between them. So notice how in this example, the pink card is transitioning, has a different bound size versus the purple card. The transition between the two doesn't entirely match on top of one another, and the incoming content overlaps the outgoing content with a different ratio. Whereas with remeasure to bounds, it'll perform a remeasure and a relayout, and transform the aspect ratio as it grows between the two. So scale to bounds is useful for things such as text, whereas remeasure to bounds is probably what we want in this case, because we want to keep the same aspect ratio between the two. So we've set the resize mode on the card to remeasure to bounds, and the animation is looking a little bit more like it with its aspect ratio. But you may notice that when performing this animation from the bottom of the screen, the bottom app bar looks a little bit strange as the shared element elevates itself above the app bar and then transitions to the final state. And this doesn't look that ideal. We'd like the bottom app bar to actually animate out of the way, but also we'd like to ensure that it's always on top of the shared elements. So how can we fix this? Well, to fix this, we need to learn a little bit about the shared element overlay and how it works. So when creating your shared transition layout, an empty overlay is actually placed at that point in the hierarchy, covering all of the content within that composable. For visualization purposes, we've added a translucent red overlay here to show what the overlay is at that point. No? When the shared element item is clicked on, the item is elevated into this overlay. So it's currently drawing above the translucent red overlay, and then the item progressively grows to its target state. And after the transition is finished, you can see that the overlay has now no matching elements rendering in this overlay, and the content is dropped back down to the original layer that it should render in. So what's happening with this particular example is that the bottom map bar is not rendering in the overlay, it's rendering in the layer below it, which makes it look like the shared element is jumping in front of the bottom map bar as the shared element transition begins. So to fix this, we can actually specify on the bottom map bar that it should also be pulled into this overlay by using the render in shared transition scope overlay. We give it a certain Z index that it should take on. In this case, we set it to 1 to ensure that it always renders above the shared element. If we had to have set this to 0, though, the shared element would render above the bottom bar, but the bottom bar is now drawn in the overlay with the shared elements. And in this case, you can see that the white background of the card isn't actually a shared element. So it's not rendering in that overlay, making this look a little bit odd. But whereas if we set it to 1, we will ensure that it will render over the other elements. And this is looking a little bit better. But not quite a great experience just yet. The bottom bar is at least rendering above the content, but we would also like it to move away as it grows between the two. So to make this even better, we can add another modifier. Adding modifier.animateEnterExit onto this bottom map bar, it'll use that same animated content transition to drive the exit animation. So combined with slide in vertically and slide out vertically, it'll exit the screen as the shared element transition goes to the other state. It looks way better than the initial rendering above. So now the shared element, the bottom app bar exits out of the screen. And we've applied the same concept to the shopping app bar on the snack detail screen too, for it to enter the screen as it comes into view. So another visual that needs to be improved with this app is that we can see as it grows into the final state, the description text, the lorem ipsum in this state, is reflowing its text as the container grows in size. Now, this is a little bit visually distracting, and we would prefer it if it maybe didn't reflow as it grows. So this leads us to talking about modifier.skip-to-look-ahead-size. So we've learned all about look-ahead in the beginning, and this modifier will allow us to skip the intermediate sizes of look-ahead and skip to the end state that the text will take on. So to solve this issue, on the text composable that's in the snack detail screen, we can add the skip-to-look-ahead size modifier onto this text. So even though this isn't an element that's actually shared between the two, the parent is the shared bounds. So adding skip-to-look-ahead size eliminates the intermediate sizes of this child and skips to the target size for that text. This allows us to improve the animation here and remove the distracting reflow of text. Okay. When talking about shared elements, though, it's useful to also understand another concept, which is clipping. So clipping can be thought of as using a cookie cutter to cut out content to a certain shape. And with shared elements, our child content that was previously clipped may lose its clipping information as it's pulled up into the overlay. Let's take a look at a quick example. So in the Jet Snack case, we have a rounded corner shape as the main content, and on the snack details, we aren't really clipping to a shape here. So it's just a rectangle, or a rounded corner shape with a 0 dp radius. So with the Jet Snack card itself, we are already clipping the card to a rounded corner shape with a 20 dp size. And when doing a modifier shared bounds between the two items, it somewhat works, but because we have an inner shared element, in this case, the gradient background, all of these children are brought into the overlay during the transition. So the children, in this case, the most noticeable child, the gradient, loses its clipping information as it's pulled into the overlay. So how can we tell that this is an actual clipping issue? Well, the item is actually drawing beyond the bounds of what we want, of the original rectangle, and in this case, we can see that it's not rounded on those corners. So in order to apply this clipping information to the children itself, we can update our composable here to have the clipping parameters set on the card and columns so that the children also get the clip applied when it moves into the overlay. But you may notice there is also no automatic animation between these two states. So when it elevates into the overlay, the final target shape is applied immediately. So in this case, from start to finish, it's a rectangle, but the other way around, it immediately applies the rounded corner shape. So the animation continues with that target shape applied. Not ideal. So we actually want to animate between these two different shapes. So we want to go from 20 dp to 0 dp. And to do this, we need to tie into the current animated visibility scope transition. So we use animate dp here, and we check the state of the visibility transition. So we set the values of the rounded corner card animation to either 0 if it's exiting or starting to enter, and 20 when it's fully visible. We then set the clip-in overlay during transition to the rounded corner shape that has this animated corner value applied to it. And on the details content, we do the same, but in reverse, since we want this visible state details to have no corner rounding of the end state. So this will give us a nice animation between the two states of our shared element transition. And your imagination can run wild with the possibilities of what can be done here if you tie into this existing shared element transition object, as you can use all the knowledge you already know about animations in Compose here. So when working with shared elements, it's important to know how modifier ordering can actually affect your shared element. Let's take a look at this example. We have of using shared bounds. We have two composables, A and B, and they both contain the text that says hello. And we wrap the content with a red border. In A's case, we have the padding modifier as the first modifier. But in B's case, we've put the shared bounds modifier before the padding modifier. And as you can see, when the elements attempt to be matched, there isn't an exact match between the two. And there isn't a really great consistency. So in order to fix this, we move the shared bounds modifier after the padding modifier instead. And what is happening here is that all the modifiers after shared bounds are considered children of the shared bounds modifier. So in the same way that your text composable is going to be shared, this modifier will be shared too. So in the previous case, when the padding was after the shared bounds modifier, it was included. But in the case where it's before, it does not get included. So we understand the basics of shared elements and how to use them in our apps. And we're going to add one more final delightful touch to the JetSnack app. So you may have heard of Predictive Back before. It's a feature on Android 15 Plus, which allows you to display a preview of where your user would navigate to if they were to perform a back gesture. So to use shared elements with Predictive Back, there's a few simple steps. The first thing you need to do is add Android manifest XML flag, enable on back invoked callback. You also need to make sure you're using the latest version of Navigation Compose, and make sure that you're wrapping your top-level nav host with shared transition layout. So because the JetSnack app was using nav host, which also supplies the animated visibility scope that we needed, we only needed to add the Android manifest option, and we can now get out of the box predictive back animations between the list and element pages. So it is worth noting, if you're going to use, you don't have to use nav host to get predictive back animations or this kind of functionality. If you're using your own navigation framework, you can support this too with a custom predictive back handler and seekable transition state. I don't know if you want to try this. Might not work. No, it is finished.
Thanks, Rebecca. Now that we've learned how to use shared element APIs, are you ready for some under the hood content? Okay, very brave audience. So as you know, there are three main stages in Compose for each frame: composition, layout, and drawing. That should be pretty straightforward. Let's see what shared element transition does at each of these three stages. During composition, we'll be matching keys. Shared content states will be created for each key, and we'll be trying to match these shared elements by their keys. This is all within the same transition scope. Only matched shared elements will animate or render in overlay, as you'll see later. And we'll also create a child transition. This is specifically the child transition of the animated visibility scope that you passed to the shared content. And the child transition will be initially empty during the composition stage. And then later on during layout, it will be populated with all of the animations that we created specifically for shared elements. And that includes bounce animation and inter-exit transitions. Now you might wonder, why do we need to create a child transition? Unfortunately, I already reviewed the answer. The purpose of creating the child transition is really to hoist all of the shared element animations into the parent transition. That way the parent has control over the progress of shared elements. Here's an example of how that's used. We have a predictive back demo here, where I'm using the gesture to seek the entire navigation transition. And as you can see, the shared elements are being seeked as a part of that navigation transition. This is only possible because all of the shared element animations are put in a child transition of the navigation. So they're being seeked as a whole. Now onto the layout stage. During the layout stage, we will be relying on a custom implementation of approach layout modifier node. This might sound a little unfamiliar to you, but yeah, this is new content. This is specifically for handling the look-ahead-based animations. If you need to build your own look-ahead animation, you will need to implement approach layout modifier node. And here I'll walk you through the example of how we implement the approach layout modifier node for shared content to help you build your own look-ahead-based animation. And there will be two passes, look-ahead pass and approach pass. And the approach layout modifier node will contain the measure and layout logic for these two separate passes. During the look-ahead pass, we'll be calculating the bounds, the target bounds for shared content. And then during the approach, we'll be animating the bounds from current bounds to that target bounds. If we look at the interface definition for approach layout modifier, you'll see there's a measure method. And this measure is specifically for look-ahead pass. In addition, we also have approach measure. As its name indicates, this is specifically for measure and layout logic for the approach pass. This approach layout modifier node interface sets up these different code paths for look-ahead pass versus approach. And that allows us to measure with target values during approach, during look-ahead, and measure with animated value during approach. And this separate code paths also allow us to prevent the animations from the approach from affecting the target calculation in the look-ahead. Now, once look-ahead pass is finished, we finally have the target bounds calculated for our shared content, as you see, rendered with the wireframes. Now we're ready to animate with the approach. During the approach pass, we can expect the layout to move gradually and smoothly towards their destination, very much like the hikers. Now, before diving into approach measure, I'd like to call out that there are two steps to measure a layout. And this is not specific to approach or look ahead. This applies to measure any layout. Understanding this could help you build your own custom layout in Compose. And the two steps are, one, measure the child content with a constraints. This could be the constraints coming from the parent, could be a modified constraints. And I'll show you an example of how we modify the constraints to measure the child. And the step two is to report the measured size back to the parent. Pretty straightforward, I hope. So now let's look at how we do approach measure for the shared content. Since we want to animate the layout during the approach pass, the first step we will do is to obtain the animated size from the ongoing bounds animation. Once we have the animated size, we'll go ahead and create fixed size constraints using the animated size. Now we're ready to measure the child with the animated constraints. And as a side note, when you measure a layout with the animated constraints, you can expect an effect like this. The layout will remeasure its children with the new constraints, and most likely will relay out the children as well to fit in the new constraints. So if in your app, you're looking for an effect like this, where not only the layout resizes, but also all of the content within the layout fits in the new size during the animation, then animated constraints could be useful. Now back to shared content. If we measure shared content with the changing constraints, then this is what we can expect to see. And this is the measure to bounds mode. You can see the text reacting to the changing constraints by reflowing. Since we also know the target size for the shared content, instead of applying a different constraints to each frame and measure it, we could just measure it once with the target size and applying a different scale each frame. And that would give us scale to bounds. Scale to bounds, as I mentioned, measures the content only once and applies different scales. It is much more performant. And that is also our default behavior for the resize mode. All right, now we've finished measuring the child. It's time to report the size back to the parent. Here, again, we have different options. We could report the content size to the parent, in which case the parent won't see any size change during the transition, so the parent won't do anything. It looks pretty calm. Alternatively, we could also report animated size. That way the parent sees the size change, and it will correspondingly resize itself and moves the other items out of the way. If we look at these two modes side by side, you can probably think of use cases for each of these modes, and you can customize which one to use for your specific use case through the placeholder size for each shared content. Now onto the drawing stage, finally. Each shared content will be rendered into a different layer. That allows us to then render this layer at different target draw scopes. For example, as Rebecca mentioned earlier, we render shared content in the overlay during the transition, and then back in their own draw scope after the transition. Having the layer capture everything that's in the shared content helps with that. The draw order in the overlay is initially determined by the composition order, meaning the shared content that gets composed first will be drawn first. But you can customize that through the z-indexing overlay. We've talked a lot about overlay, and especially in the jet snack example. But since overlay is such a critical part of how shared elements work, I'd like to give you some inner workings and also show you some of the design decisions that we made along the way, so hopefully you understand the behavior better. If we recall this slide from earlier, we have the shared transition layout added as the parent of animated content in order to create a shared transition scope, and the shared transition scope would then allow us to create shared elements. In fact, this shared transition layout also creates the overlay. If we look at the implementation for shared transition layout, we can see that aside from a lot of scopes that we created, they're all necessary. Aside from these scopes, shared transition layout really is just a box with modifiers. And if we zoom into the draw with content modifier, we can see that the overlay logic is kind of strategically placed after draw content. And that's how we achieve drawing everything in the overlay over everything else in the shared transition layout. You can almost think of the overlay as an additional foreground of the shared transition layout. And because of that, it has the same size and position as the shared transition layout. What that means is whether your overlay covers the entire screen in your app or part of the screen, whether it renders on top of your floating action button or underneath your bottom bar, that's entirely dependent on where you create the shared transition layout. Rebecca has mentioned quite a bit about the challenges with overlay. For example, shared elements that get rendered in the overlay may render over the bottom bar, unless we also bring the bottom bar into the overlay. We've also seen that sometimes the child might lose its parents' rounded corner clipping unless we explicitly specify overlay clipping for the child. Now, why do we choose to use the overlay in spite of all these challenges? There are 3 reasons. And interestingly, these are the same reasons why they were challenging. The first reason being, most of the time, we want the shared elements to escape its parents' clipping, like we see here. especially when the shared element moves away from its previous parent into the new parent. And if we did apply the clipping, it would look like this, the example on the right. The red border indicates where the parent clipping is. As you can see, this doesn't look ideal. And the second reason is that we want to avoid having shared elements faded in or out by the parents, especially for shared elements that have found a match. We want the shared element to stay fully opaque the entire time during the transition, as you see in this animation. Otherwise, we get the effect on the right, where the shared element fades in with the incoming content. And that breaks the illusion of shared element being this element that provides continuity in between the transition. And by elevating shared elements into the overlay, we effectively avoid taking on any alpha changes coming down from the tree. The third reason is that most of the time we want shared elements to render on top of everything else. Otherwise, you may see shared elements going underneath other layouts. All right, now we have concluded the inner workings of shared elements in all these three stages. I hope that provided you with a different perspective to look at shared elements and understand its behavior.
Thanks, Doris. We now have a beautiful shared element transition between the snack and details, and the ability to seek between the two screens with predictive back. And we've learned all about how shared elements work under the hood. We've also seen a lot of great examples of shared elements implemented by Compose members of the community, and we can't wait to see what you build with the APIs. So for more information covering these examples and concepts that we've covered today, be sure to check out the docs that covers things such as the different API limitations, how to use animated visibility, and more. So we will be around for office hours starting at around 12:40, and we are around at the conference as well. So please be sure to find us if you have any questions. Thank you so much.